Hi, I'm Dermot O'Driscoll, and I am in charge of go-to-market and customer solutions in the Physical AI business unit at Arm. Today, I'm super excited to be talking to Dr. Aadeel Akhtar about his company, PSYONIC, and the incredible work that they're doing around prosthetic limbs. Can you tell me a little bit about PSYONIC?
Yeah, so at PSYONIC, we are solving dexterity for humans and robots. And we do that through bionic hardware like the Ability hand, which is both a prosthetic hand that goes on humans, as well as on robots.
I'm very curious, what is different about how you're addressing this problem from traditional approaches?
We started in prosthetics. So our hand is both a prosthetic hand as well as a robot hand. What's unique is that anything that the robots are trying to do, our humans have figured out how to do that as a prosthetic device. So our human users can actually train the robots to do the same tasks that they're able to do.
Can you help me understand how the hand operates and how these processors are driving it?
The most common way to control the hand is through two muscle sensors. So one that's placed over your wrist flexor, so it's when you bend your wrist in, the hand closes, and then one placed over your wrist extensor. When you extend the hand out, the hand opens back up. So those are analog signals that will send through the hand, and then the ADCs on the ARM microcontroller will then translate that to the correct positions and the velocities of the fingers that we're trying to move. So we have a central microcontroller that takes in all of that, all of the muscle signal data, and it coordinates that all instantaneously on the order of milliseconds, so that it happens much faster than the 200 millisecond close time of our motors, so that there's no lag when the user is trying to control the hand. So for each of the sensorized fingers that we have a small low power microcontroller that we have in the fingers that can take all the touch sensor data and then communicate it with the ARM microcontrollers that are in the palm, and then send that to the user through a vibration so that they can feel exactly how much force that they're applying on the object. And so our users have been able to grab raspberries without crushing them, or hollow eggshells without cracking them.
I know you have somebody who works here who has first-hand experience of using the prosthetic.
Absolutely, and I'd love to introduce you to our creative marketing manager, Dale Demasi.
Fantastic.
Dermot, nice to meet you. I'm Dale.
Dale, that is amazing. That is good to meet you. Can you tell us a little bit about your experience with the prosthetic?
Yeah, so after 30 years of not wearing prosthetics, I decided that this might be a good fit for me, this hand. And it's definitely worlds different than any other prosthesis that I've ever worn before. You know, mainly the speed at which it moves. I don't have to slow down my activities to the speed that my hand operates at. It operates at the speed of the rest of my body. And the touch feedback is really valuable. Just having that confidence of knowing when I grab something and I pick it up, that I actually have it, and that I'm not gonna drop it. In the same way I let go of something, that I know that, I'm gonna place it safely, move my hand out of the way. The little things that you kind of take for granted that make a huge difference when you're talking about a device that's helping you with how you interact with the world.
So that data, in physical AI terms, people call that the real data that informs the simulation data. How is that data helping you develop a product that is not just for prosthetics, but also for robotics use cases?
So the beauty of this is that if you're building a robot to do human tasks, we've optimized our hands for humans to do human tasks. So it makes sense that the robots use the same thing. And so because of that, our human prosthetic users can actually train the robots to do the exact same tasks that they're able to do. When we're able to stream the data that's generated by the Ability hand into Isaac Lab, for example, we're capturing all the data in simulation where we've got all the touch sensors, all the movements of the hand, all the positions, velocity, torques, and then we can then take that data and then bring that to their visual language action models like Groot, and then use that to train the robots to do the exact same thing.
All of those are leveraging NVIDIA's ARM-based platforms.
Exactly.
Is that helpful to you, that it's sort of ARM in the palm of the device, plus it's ARM all the way up to the training and the simulation?
Exactly, and knowing that we can rely on a chipset that is just going to be consistent across every system, that's really important to us, because we know that if it works here, it should be able to work in any of those other systems.
What do you see as the future for you and for PSYONIC?
Yeah, where we're heading with this technology is seamless integration between humans and robots. And so on the human side, we're directly connecting the hand to your muscles, your bones, and your nerves, so that you can enable individual finger control and touch sensing that actually feels like it's coming from your missing hand to unlock true dexterity. And then that, in turn, will unlock true dexterity for the robots to do much more complex tasks than they've ever been able to do before.
I'm really excited about what the future of bionic technology means to people in the limb different community and what it means for their outlook on life and with the possibilities, just the amazing things that we're going to see people do that people would never thought were possible.
What I've learned today is just changed my whole perspective on this space, right? So I'm super excited about what you guys are doing, and to see the way that you're developing at scale and looking to develop at scale and bringing down cost and leveraging off-the-shelf solutions to do that makes me super excited for you guys.
The future is going to be exciting.